Okay, here we go. The new study guide. So let's just jump right in. You got visual clues on the front, and the first question starts here. What are the ADA wheelchair ramp requirements? Google it, and then draw a picture of one that would comply. So you could Google it, or they are all right here as well. But let's see if I can get them. So the very first one is side ratios, 1 to 12, angle, max of 4.8 degrees, and then the last one is width of 36 inches. And then they ask us to draw a picture of one that would comply. So for this, I recommend you use a trusty protractor. And you can also use a ruler. Okay, so why don't we do that right here? So when you say the side ratio is 1 to 12, your horizontal is 12, and your vertical is 1. Okay. Okay, so what we're looking at here, 1 to 12. This angle right here cannot exceed 4.8 degrees. And then it's got to be 36 inches wide. So there you go. Okay, number 4. We skipped 2 and 3. So use the ratio table to find the launch angle of the plane. Opposites 250, adjacent is 1000. So here is your visual launch angle of the plane. Horizontal 1000, vertical 250. Okay, so how do you do that? Well, I'm just gonna draw a picture up here. So 250, 1000. We got to figure out this angle right here. So the first thing you do is you color. This is the plane's path up here. We just call it A. Opposite 250, adjacent 1000. So we've colored in our angle, we've labeled our sides, op, adjacent. Now you gotta write SOHCAHTOA. And then we're looking for the O and the A, so we're gonna go with TOA. You say tangent of A equals op over ADJ, which is 250 over 1000 which equals 0.25. So you eventually get tangent of A equals 0.25. Now, once you're here, you gotta do one thing to get the angle. Show you how to do it on both calculators. So the first one, so again, you're here, tan A is 0.25, so you just go second tan 0.25 equals, that's 14.03. On this one, you just go 0.25 second tan. So there is your angle, 14.03 degrees. So 14.03 degrees. Now, I kind of jumped the gun here. I forgot to use the ratio table. I used the calculator, but that'll show you the answer to number 9. But let me show you how to use the ratio table. So remember, tangent, we got 0.25. So if you're using the ratio table, you just go here. Here's the ratio table. This is opposite over adjacent, or in other words, tangent. And you just look for 0.25. 0.25 falls in between these two. So you know it's in between 10 and 20. And then if you did the math, you would realize it's a little bit closer to this number than it is this. So 0.25 is just barely closer to this than it is to this. So I'm gonna say, I wouldn't say 15, because that would be like equal in between, right in between these two. But it's a tiny bit closer to this one, so I'm gonna say 14 degrees. So that's how you use the table. Anyway, killed 2 birds with 1 stone by jumping the gun a little bit. Well, let's go back to all the questions. Okay, so remember, you got this sheet, and we got 10 questions. Okay. All right, so 4's done, 1's done, 9's now done. Now, number 5, here we go. We have to draw a right triangle and a rocket. Then calculate the launch angle if op is 50, adjacent 13. Okay, so here's my rocket drawing. Let's go over here. And we're blasting off into space. Okay. You got this rocket here. Get some flames coming in here. Rocket fuel. Give this rocket some color. There's the hatch for here. Okay, so you got this rocket, right? Now, we're talking about launch angles here. Let's see if I can get this. It's not perfect, but that's okay. It's all about the math. Okay, so here's your figure. Again, we're on number 5 right here. Okay, now we have to calculate this rocket's launch angle, which we'll just call A right here. So we've got to figure out what is this. Now what they're saying is opposite is 50 and adjacent is 13. So first thing, here's your steps. Color, label, write, choose, and then do. So for me it's 5 steps. So color in the angle is the angle we gotta find. Label your sides. So this is opposite, this is adjacent. Adjacent touches the angle, opposite does not. So we have colored, we've labeled. Now what do you write? I write so, ka, toa. That's done. And then you choose, the one has the O and the A, which is toa. And then you just do some math. Tan A equals, so we choose, now we're doing op over ADJ. So tan A equals 50 over 13. Tan A equals 3.8. So once you get here, you're one step away. You just gotta do, on this calculator, second tan 3.8. You'll get 75.25. On this one, 3.8 second tan, 75.25. So we're just gonna round that. So angle A is 75 degrees. And there you go. So we calculated the launch angle, we drew the right triangle, and we even drew the rocket. So, cool. Okay, number 6, what does SOHCAHTOA mean to you? Well, for me, I like to do these bubble letters. It's always helped me through the years. Some of you are beyond that, and you don't need them. But I'm gonna do it anyways, because it works for me. So, SOHCAHTOA. All right. This S stands for sine, and then it always equals opposite divided by hypo. Opposite divided by hypo. So there's sine for you. This C right here is cosine. That always equals adjacent divided by hypo. And then lastly, tangent always equals opposite divided by adjacent. Now, what does it mean to me? Well, SOHCAHTOA is known as a mnemonic device. And mnemonic devices are used to remember things. Now, you've probably seen this one before, PEMDAS, parentheses, exponents, multiplication, division, addition, subtraction. Or maybe you're in the medical field and you're a doctor and your patient broke their ankle. There's something called the RICE method. So I've broken an ankle and I tore my Achilles. RICE stands for rest, ice, compression, elevate. So even outside of the geometry world, mnemonic devices are great for learning psychology. They help you remember things. So that's why I use SOHCAHTOA so much, because mnemonic devices are so helpful. So you might not remember sine, cosine, and tangent, but you may remember SOHCAHTOA. And just have both ready. SOHCAHTOA like saves you so much time. All right, number 7, find the height of Hyperion using trigonometry. All right, let me zoom out a little bit. Okay, so we've got the wheelchair ramp, we've got the rocket. Here comes our tree. Just want to make sure to get this somewhat looking good. Oh yeah, so here's our tree. Now with trees, I've always done them like this. Start with the trunk, and then talking about redwood trees, so I'm just gonna go like this. A little bit bigger. Draw that one a little smaller. And then just make the cone shape going up. I know I'm not an art teacher, but probably can help you with the drawings a little bit. So anyway, you got your tree, right? So redwood, so I'm just gonna make it like reddish. All right, so here's our redwood tree. Okay. Now, now remember, we're trying to find the height of Hyperion using trigonometry. Now, if you were to look up at my whiteboard or on the other side of this page, you'd see the measurements you need. Now, here we go. You're gonna be like over here. So here's you. Imagine you like pointing up at that tree. So you are looking up at this tree, right? I'm gonna say there's a couple different ways you could shake this one out, but let's say you are 220 feet away, and you have to look up at a 60-degree angle to see the top. Pretty easy from here. Just gonna color this in. You color, label, write, choose, and do. So we colored. Now we're gonna label. So height. This is ADJ. This is OPP. Then we're gonna write SOHCAHTOA. You're looking for the O and the A. So we're gonna go with TOA. All right. So you've chosen. Now you just gotta do some math and you're good. So TOA, tangent. And we'll just call this A. This is U. Tan A equals OP ADJ, which equals height over 220. And then we're saying tan of 60 equals height over 220. Tan 60 is 1.732. So then you'll just put these equal to each other. So we'll do that right here. 1.732 equals height over 220. Throw a 1 under there, cross multiply. And you're gonna get the height equals 381.05 feet. So, tallest tree, Hyperion. One of the ways you can figure it out is just get this length and then get the angle of elevation to the top. And then you just do color, label, write, choose, do, and that's it. That was 7. Let's go to 8. What is the relationship between complementary angles? You got to use this word bank: sine and cosine. All right, so you need to know 2 things about complementary angles. Complementary angles are two angles that add up to 90 degrees. So you got two angles that add up to 90 degrees. The other thing you need to know is that sine of one equals cosine of the other. So what are some examples of two angles that add up to 90? How about 80-10, 70-20, 60-30, 50-40, or why don't we say 88-2? So what you'll find is that sine of 80 equals cosine of 10, cosine of 70 equals sine of 20, sine of 60 equals cosine of 30, sine of 50 equals cosine of 40. Now, you may ask yourself, why? Fisher, why is that true? Well, I'll show you why. Let me draw you two right triangles. So I'm trying to show you why. So this is 30, we'll say. We'll say this is 60. Meaning they're both 90, 60, 30. 90, 60, 30. Why don't we call this X, Y, Z, X, Y, Z. So let's color in this 30. We'll do sin 30. Sin of 30 is opposite over hypotenuse, so that will equal X over Z. Let's go to this 60. Let's do cosine of 60. Op, adjacent, hypo. So sin of 30 was op over hypo. Now we're going to do cosine of 60. Cosine of 60 equals ADJ over hypo, which is also X over Z. Now, why is that? It's because depending on which angle you're looking at, op, adjacent, they end up switching on you. So that's why sine of 1 equals cosine of its complement. Okay, find the launch angle of the plane using the calculator. I already showed you how to do that, so we're done with number 9. Number 10, somebody had asked me, somebody wants me to come in, actually came in today, and I ended up going to another meeting, so I couldn't make it, but I promised this person I was gonna do that. So let me find some space to do it. I'm just gonna get a blank sheet of paper. The question is, construct a regular hexagon inscribed in a circle with radius 1 inch. Find its area and perimeter. Okie doke. Let me get a scratch sheet. This is a super fun problem. Okay, so again, regular hexagon inscribed in a circle, radius 1 inch. So regular hexagon. Zoom out. So regular hexagon inscribed in a circle. Radius is 1 inch. Okay, that's my givens. Okay, I need area and perimeter. Love this problem. That's what I'm looking for. Okie doke. Start with the center right here. Draw this as big as I can. Okay. Pick a point on the outside. I'll show you a little tip that can save you a bunch of time. Just do a little test run. Okay, it goes right through it. These 2 points. Now, here's one of the vertices of a regular hexagon. There's another one, and there's a third. Now, one thing you could do, it's kind of a little cheat code. Just get a ruler, make a mark over here. Get a ruler. There's a straight line. Goes through all of them. Gotta get a ruler though, don't eye it. Okay, these are your points, regular, for a regular hexagon, these are your vertices, right? So let's start connecting the dots. 1, 2, 3, 4, 5, 6. Okay. Just to triple check, let's make sure the sides are the same. 6.4, 6.4, 6.4, 6.4, 6.4, and 6.4. Okay, cool. Now, I said the radius was 1. What I'm going to start doing is creating 6 radii. Just go point to point. Easiest way to draw the line, just put the pen on the point. Set your ruler up, bring your ruler to the pen, and then draw. Okay. Now, you've got your 6 triangles, right? And we have a, hold off on that. We've got our hexagon inscribed in a circle. Step 1, draw another little circle. Doesn't have to be perfect. Just have to get the center, or it doesn't have to be a specific radius. You just have to make sure you use the same center. Now, this is like an auxiliary circle, a circle that helps you. Now, what's cool is this will help you visualize it. So a circle, as you know, has 360 degrees. A regular hexagon, each one of these is going to be the same. And there's 1, 2, 3, 4, 5, 6 of them. So you just divide it by 6, and you end up getting 60 degrees right here. So that's a 60-degree angle, right? Now, it said the radius was 1, meaning that's 1 because that's a radius, and that's 1 because that's a radius. Meaning, we've got what's called an isosceles triangle. Now, because of triangle sum theorem, we know that this plus this plus this will all equal 180. Because it's isosceles, because these are both 1, that means these two are the same. And because we already have 60, this plus this will be 120. And they're the same, so these are 60. So not only do we have an isosceles triangle, we actually have a equilateral triangle, meaning this outer edge, or this outer, one of the sides of the hexagon is also 1. And because it's a regular hexagon, this is 1. This is 1. This is 1. This is 1. And this is 1. So 1 plus 1 plus 1 plus 1 plus 1 plus 1. So 1, 2, 3, 4, 5, 6 is our perimeter. So perimeter of this one equals 6. And specifically inches. So the perimeter of this regular hexagon is 6 inches. Now, area gets a little tricky. What we're gonna do is we're gonna use one of these triangles and we're gonna draw what's called an altitude. Now, an altitude forms a 90-degree angle, right? You already showed me that this is 60, or I already showed you that that's 60. This altitude creates a 90, meaning this is 30. We already know this is 1 because it's a radii, or a radius of the circle. We already know this is 1. Let's start calling these something so I don't just keep calling them this. AB is 1, right? Okay, so AB is 1. I'm just gonna color that in so we can identify that. 1 is the base. So we got a base equaling 1, right? Okay, now we gotta get this H, which is known as the height. So once we can get the height of this triangle, we already have the base. We're going to apply the area formula, which is 1/2 base times height. So that's not an x, it's times. Okay. So 1/2 base times height is the area of a triangle. Now, I'm gonna direct your attention to this orange triangle. Let's just focus on this orange one. Okay. Now the goal is to get the height. Now, let's color in the 60. So, color in this 60 right here. If you have to rewrite the 60 outside of it, not a bad idea. Okay, so remember we got a 60-degree angle right here. Okay, now you start labeling things. Height is the opposite. 1 is the hypo. So at this point, we're at color, label, write, choose, and do. So we colored in the 60. We labeled op and hypo. We're gonna write SOHCAHTOA. We're gonna use the O and the H. So we're gonna go with so. At S, sin, the angle 60 equals opposite over hypo. Sin 60 is 0.866. I just use the table, which I have on my whiteboard. It's also, just to clarify, this is where I looked, right here. I've got the table on the whiteboard. So if you ever like are here, where'd I go? Oh, shoot, sorry. If you're ever here and you're like, shoot, what is sin 60? I don't have a calculator. Well, you always want to have a calculator on you, but you could always use the front whiteboard, which is what I just looked at. But anyway, 0.866, that's sin 60, That equals opposite, which we called h, over hypo, which is 1. I like to do this step just in case I make some errors. H times 1 is h. 1 times 0.86 is 0.866. So your height now is 0.866. Okay? Just stay with me, don't lose me. Now, you have the height. You've got your base of 1. You have your formula. So now it's go time. So let me just color that in. Here's your formula. Right here. Which means you gotta use this puppy. 1/2 base times height. Let's just do it right here. Area equals 1/2 BH B1. So 1/2 of 1. Height 0.866. This is why it's so helpful to label your figure, and then you just go like this. 0.866 times 1 is 0.866, half. And you could, if you don't know it, go like this: 1/2 in parentheses times 0.866, and you'll get 0.433. So your area equals 0.433. Now, that's of an entire triangle, right? 1/2 the base times the height. So your whole area is 0.433 of this triangle in red, which I'm shading in red right here. Just to help me visualize it. How many are there? 1, 2, 3, 4, 5, 6. So there's 1, there's 2, there's 3, 4, 5, 6. I won't go into exactly why these are all congruent. Although, here's a quick one. Side, side, side. They're all 1, right? We already showed that. But anyways, got 6 of them. So you just go 0.433 times 6. And your area is 2.598. So this entire thing in purple, this is your area of the regular hexagon, is 2.598. And that's it. I think I started at the 23, it's now at 38. That's a 15-minute problem, fully explained though. With pretty good work, I feel like. I feel like that's pretty neat. Anyways, area 2.598. Now you're in inches, so you just put inches, but you just put a 2 right there. That's just your label. Or you could have said square inches. But this is your final answer. And that represents the area of the regular hexagon inscribed in a circle with radius of 1. All right, now let me explain what you got here. You've got lesson 1. Now, if you really get bored, you need something to calm you down, try using this as like a coloring book. We'll just do one for you. These are all the colors of the pool balls. I like to play pool. I see a lot of geometry in the game of pool, so makes sense. It's also the way I'm using my coloring book for this one, but this study guide serves as like a coloring book too. So if you're getting like super stressed out for whatever reason, this also can like help you de-stress, which is a big part of life. So you can color in all these, whatever. The keys, I traced all my keys. Anyway, your learning targets there. I gave you a sample problem, first step. I gave you the key learning target. And then you go to the next one, which is lesson 4. Learning target, sample problem. There's the plane problem again, in case you want more of that action. Here's your ratio table. These are all tools that you can use on the tests. Lesson 5. 3 sample problems plus the learning target. Here's lessons 6 and 9, which is SOHCAHTOA, the breakdown of SOHCAHTOA plus the steps plus a sample problem. If you flip it over, it was kind of silly, but I could see through the page, so I just like wrote SOHCAHTOA again, but drew it within a wave. If you ever want to learn how to draw a wave, let me know. Anyway, I gave you 2 options. One where they give you an angle plus one side, and you have to solve for another side, and then another one where they give you 2 sides, you have to solve for an angle. Okay. Lesson 7 is your tree. Hyperion. Lesson 8 is the complementary angles. And then these are challenging. These are very similar to this one, where you've got a bunch of different like circles with clearly identified points. This one is tough right here. If you can get this one, I'd be pretty thrilled. You've got a radius of 1. And you gotta find the area of this equilateral triangle. Challenge. I challenge you to do that. Find the area of that equilateral triangle. Anyway, there's a bunch of problems that you can like practice all these. So plenty of stuff to do. Test is Thursday, Friday, which is January 30th and 31st. So we're gonna end up January with the Unit 4 test. We'll start fresh in February on Unit 5. And just keep working hard. Use that creativity and create some cool stuff too. All right, adios.